That's what I was told, and I heard some different things, but I'm sure. What?
Okay, hey, you need to have your notes out. You have 5 minutes.
What? For what?
5 minutes. Fill that out.
Pointer?
So, do you have a piece of paper out?
Right now, 5 minutes, or?
Oh,
You
no.
need a piece of paper? Put your answers down to that paper.
What if I tell you
Stop.
that
I
I
borrow
borrowed
your
your
name.
paper?
What?
What if I'm...
Put your name on the paper.
Can I see the back of that shirt? Can I see the back of that shirt? Like, take it off, type shoes. I'm not playing anymore, but my fingertips are there. It makes me feel good.
Is this graded?
It's probably like the 5-pointer.
Hey, you need a piece of paper. Piece of paper, you have 5 minutes to answer those questions called that picture. You can have a little piece of paper with your name on it.
I've got a half piece of paper.
I think I have a 5-pointer right now.
Good. Ryan, answer that one. At 1:30.
Right.
I got you.
I think I wrote 31.
You have it with me?
Yeah, no kidding. There's your hat.
Thank you.
Spencer, what do you want? Boy, tomorrow night, yes or no? Oh shoot.
Yes.
Possibly? Huh? Possibly? I'll ask him tonight.
Alright. 5 minutes. I want to see what your answers are for this picture. Here's my question. Do I need to turn the lights off for the glare?
Not bad.
Your eyes all right here. What kind of crazy plan you got, Kurt? You got a crazy plan going, I can see it. There's smoke coming out of your ears. I can see it. You really
What the heck is relative max? Oh, I got you.
You actually?
Go ahead.
Or just a second.
What's wrong?
Make sure your name's on the top of your paper. I'd like you to take your piece of paper and hand it to the person behind you. Now, if you're in the back, you have to hand it all the way to the front. So just have your notebook back. Hand it all the way to the front.
I was looking for a girl.
You didn't like him or?
Yeah, I have nothing, so.
Okay, everyone got their paper? The person behind them. Alright, now, you're probably wondering what I was doing asking people 1 through 4. So, how it worked is, Spencer, you said the number 3, so it goes 3, 4, 1, 2, because it was just the numbers 1 through 4 in a big circle. You said the number 2, so it's 2, 3, 4, 1. And this is 1, 2, 3, 4, because you said the number 1. 4, 1, 2, 3. It's just a cycle, so 4, 1, 2. And here's number 1. Now, what was the number you said? 2. Who's have to answer the questions? So, number 2. Star. You're my first one. You're the second one. Nick, you're my third. And Tanner, you're my first. Alright, ready? Alright, here we go. Okay. We're gonna start here. Alright, name the domain of this function. What's the domain? Say it again. No, you don't have the option.
I don't think I got it right though.
Give me any guess you can think of.
I have -3.
I'll agree with the 3 idea. No. Arrow, what does that mean? Yeah, so negative infinity. So negative infinity, all the way up to 3. Now, 3, what do I need at the end of 3? Bracket. Alright, does that help you out? Okay, if they did not have that, mark it off. Wrong. Okay, if it's fine, leave it. Alright, range. So, second row. Who was it? Alright, Belle, what do you got? Negative infinity to 4, and what do I need at the end? Bracket. Alright.
If they don't have the returning
Yeah, and ends at 4. We're not doing the increasing, decreasing idea. Okay? Alright, questions, comments. So if they had that, you're good, leave it. If they don't, check it off wrong. Whatever. Okay. Zeros. Who is Nick? You're on it.
3.
3 and? Negative 3. Alright, there's your zeros. This is the zeros. Zeros is a big fancy way of saying x-intercepts, if you don't know. The book gets a little creative on how they ask it. Okay, so zeros, it's -3 or 3. So you gotta have both. So, all right. Next, who are we on the back row? Okay. 3 times 0. I mean 0, 3.
Oh,
0, 3. Okay, that's f0. In fact, the actual correct answer is just 3. But if you put 0, 3, I'd accept that. Okay, because that is the actual coordinate. 0 plugged in 3. All right. Questions on the first 4. Another number, please, not 2. 1. 1. Okay. You're 1.
No, I'm not.
You are.
4.
No. Oh yeah. You're 1. Oh, you're 1. I looked at the one. You're 1. 1. So that puts in your 1. Okay, 1. And 1. Alright. So you had no choice. Alright, here we go. Okay. Okay, so who is starting the first row? M. Intervals in which you're increasing. So now, this is the part where we have to worry about putting parentheses when there's inflection points, when there's the turning point. We're not going to include them, so we're saying the same with what the book is you may expect. Okay, so where is it increasing? Going up to the right. Where is it going up to the right? Negative infinity. This point, which is 1. Negative infinity up to the number 1, and you're not including the 1 because it's literally shared. Okay, count it wrong. Right or wrong? What do you got? All right. Okay, so that's increasing. Now I know there's an arrow over here, but remember when you're doing increasing, it's up to the right. You're using the x numbers, and we don't include that point because that's the turning point. If there was a solid dot there and no arrows, then fine, or there was no continuing, then fine, you put a bracket. Okay. Decreasing, what are we on the second row? Okay, Allison, where is this thing decreasing?
Yeah, but I got that one wrong.
Where is it decreasing? I want to know, hey, I want it from you, not anyone else.
Well, I don't know it.
Well, you don't need to look at your paper. Where is it going down? Give me the x numbers.
Like 1 what?
1, 2.
1, 2.
1 to 1, 2. Hey, 1 to 3. Now.
Yes.
Okay, 1 to 3. Now 1 has a parenthesis because it's this spot right here. This thing is going down from the number 1 all the way to 3. And what do I need at 3?
Right.
Wow, you got lucky. You got lucky.
That was my bad.
Yeah. All right. All right. Hey. All right. Notice that. Now we didn't include the number 1 because that's where it was the inflection point. Remember, using the x numbers for decreasing. All right. Find the values of x, which this thing, for which f of x is less than or equal to 0. So now I want the x numbers that make this thing less than 0. So we're on this next row. Okay. Where's this thing less than 0? Look at the graph. Less than 0. Where's this graph less than 0?
Oh.
Hey, no. Where's this thing less than 0? Left. I agree. It's to the left of what? I want all the numbers down here. Where is it down here?
From -3 to negative.
Okay. So how do you write this? You have to go smallest to biggest. Negative infinity up to -3.
If we wrote it backwards, is it wrong?
Was that really?
We wrote -3 to negative.
You got to write it like that. It's got to be counted wrong because you got to go least to greatest, and we include the -3. Now, what it means by less than 0, you are below the y or below the x-axis. So you got to give me the x numbers that would give you there. So that's anything that is to the left, which I agree with, -3, but that's negative infinity up to the -3, and it's including -3 because it could be equal to it. Okay, that question we haven't seen. That's something that you just had to interpret. All right. What are we on this last row? We're at. Okay. What do we got? Where are we? Where's the relative maxima at on this picture?
I don't think there is one because it's like.
Is there a maximum height?
Yeah.
Yes. What is it? Say it. 4. I agree with that. Now, when you want to know the maximum, that is a maxima. Maxima is a maximum. It's just a fancy word. That's how the book says it. Now I need the coordinate for it. 1, comma 4. 1, comma 4. That it is a relative maxima at this point, even though they don't ask for an absolute. I agree with it's an absolute right now. I agree with that, but they just ask for a relative max, and we'll just get that one. So no, if you have 1 for it, you're fine. Now here's the thing: if they ask for a relative max and don't ask for absolute, I would list that. If they ask for absolute and relative, I would say that there's just an absolute on this front. That's what I would be saying. So that would be your absolute max, right? Okay. I agree that relatives are the ones that are smaller than this, but for right now, if they don't ask for the other ones, I'll just list off what those maxima are. So I agree. This should have been absolute. I completely agree with that. Okay. Absolute.
Since we noticed that we should know.
I don't know, because I've already been tell from the top questions. Wrong. All right. I can just get a feel for it. All right. Values for which x is 4.
1.
1. Yeah, that was good. So, where's this thing hitting 4 on the y-axis? It's at 1. It's your actual maximum number. Is that relative, or I should say, it's the absolute max. Okay. F of -1, positive or negative. So where are we at? So new number, please. Not 2 and 1. 3. 3. That is you. Yep. Just say what is F of -1? Positive. Okay. Positive 2. I agree. It's positive. They ask for positive. So positive or negative. So when you plug in a -1, that is positive and it is 2. If you need to know what the number is. Okay. You just have to write positive or negative. That's all I want. All right. Even, odd, or neither. So we're on the second row. We're on to. Yep. Berkey, what do you got?
Neither.
Neither. I agree. Why? Yeah. It's not even close to being symmetrical. The right and left side of the y-axis. Don't even look at this. So, okay. So out of these questions, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 11, put their score, hand it back to me.
What the score could give half points?
What?
Could give half points?
No. It's all or nothing.
I don't remember one now.
Makes me worried.
There's no half points.
Makes me worried. I'm not gonna lie.
So that's how I got it. Not at all.
Tyler, you wrote this shit.
I don't know.
I want to get a feel.
Well, I didn't order any of the right answers.
Me too. Oh, okay, she got 4.
I was blank.
I got 5 of them.
All right, hey, I want to give you an idea. If that was a pop quiz day, which it was not, that's why I was grinning. It wasn't your pop quiz day. I want to get a feel for it. If you got higher than a 7, you actually passed it.
What you got right on?
7, you had just at 65%. So you're probably crapping yourself now. Yeah, we need to get better at this, especially these questions. These are the things we've been going over the last week. So now you can get a sense for if I gave you a pop quiz today, a lot of you would not have passed this.
Doesn't mean it's not great.
So, all right. Hey, I want to do that. So I want to see where you're at, honestly, without anyone helping. Okay, so now you get a sense for what you need to kind of work on today and tomorrow. Especially since we have homework on some of this stuff, you need to know how to do it. Okay? All right. Let's go to the new stuff today. So you can put that away, take out your notes. So if you want, yeah. Yeah, so hey, I'll collect those.
Thanks, guys. You already like looked at mine twice.
Jackie, I'll just take a picture of yours if it's in your notes. So.
And I knew what I did wrong too.
I know, the moment you said it, I was like half a low.
All right.
Solid 19% or 18%.
I would have had more time to write them off. I know, it was so graphic wall. I was wrong.
No, we did for real.
Yeah, no one. We honestly,
Not more than that, that makes sense.
Oh, yeah.
Monday.
What's up with older than everything?
5.
That's Thursday.
I only do
And I got from the rest of it. I was asking
Monday.
She goes, listen, I group effort. I'm like,
I don't work on Tuesdays. Tuesdays is the only day my restaurant closes. Or Monday's the only day my restaurant closes.
I mean,
I think I'll do
All right. Hey. Okay. You need to take out your notes. We're going to talk about a couple things today. All right. Number one. Okay, we need to talk about your piecewise functions. We haven't got to that yet, so we need to make sure we talked about it a little bit on Friday. We need to make sure we can cover this overall. Okay, and then we're going to end with differential quotients. Okay, that's the part we have to end with. Okay. So, all right. Okay. All right. So let's talk about piecewise. All right. So on a piecewise function. What do you remember talking about on Friday? What is a piecewise function? What does it look like? Could have 3. I agree with that. Could have 3. And you said equations or problems, right? Exactly. Like on a graph, you're making different types of pictures. Now, we've said the number 3 because that was an example I gave you on Friday, correct? Piecewise functions can be any number of functions, not just 3. It could be 4, it could be 200 of them. And what you're doing is you're graphing them in one single graph. And the big deal is that they have different domains. So you're going to have different things going on with the picture. So how this works, they usually give you a name of your function. And then they're going to have some curly brace. And over here, they're going to have some number of functions. I have no idea how many they're going to give you. But they'll give you some number of functions. We'll stick with 2 for right now. And they're going to ask you to graph over a certain domain. Like this. Or something like that, where there's like breaks in the graph. That type of thing. Okay, so the top one, let's go with like negative x plus 3, and the bottom one is going to be just let's go half x. So we have 2 different graphs going on, and I want to see how this works. How does it look? Okay, so the top one. This is the actual like function. That's the function. Now let's take a look at that one. What would that look like if you were to graph it? Line, curve, dot. What is it? Line. It is a line. And how did that? How is a line? That top one. Why? Doesn't have powers. That's a big deal, right? It doesn't have it's not curved because it doesn't have powers on it. Now it's not a dot. The reason why it's not a coordinate is because we have a pretty big domain, and this is going to make a line since we're not just doing one single number. We're not just doing like when we're at, it's not just, the domain over here is not just one number we're plugging into it. We're plugging in a whole series of numbers into this thing, so it's going to actually make some type of graph. Now, if I had an actual graph that would appear up here, it would crash on me. All right. So, on this graph, what number should I start with? 1. Now, I always start with this number no matter what. Even if they allow me to include it or not, you need to start with that number. Okay? That's a part of your domain. So I'm going to start with the number 1. Now I can include this number, but my x's have to be greater than or equal to 1. So we will try 1, we'll try 2 like you said, and we'll try maybe 3 or 4, something like that where we get a feel for where this thing's going. But I'm going to plug the number 1, since I can include it, right? I'm going to plug that in here. So if I take and I plug in the number 1 into this function, what do I get? 2 out of it, right? Because that'll make a -1 plus 3, which is 2. So at this spot, I'm going to be graphing this dot, and it is actually filled in. The reason why it's filled in is because I can include it. It'd be equal to that. If I couldn't include it, it'd be an open circle. Now I'm going to try the number 2, because I need to pick numbers greater than 1. So we'll try 2 here. What number do you get out of this thing? 1. Because it'll be -2 plus 3, which is the number 1. So at the number 2, I'll be at 1. So where is this thing going?
Down.
Down. It's going this direction. It's a straight line, and notice where I started. I started at 1, and I went past it on the x-axis type of thing. So there's where your graph's going. That is the first graph. Now the second graph is different. This one. I can only use numbers that are less than or equal to -3. So on my graph, here's -3, 3, and I'm going to graph that one. So I'm doing this bottom graph now. I'll do it in a different color here. So I'm going to plug in -3 because I always try this number first. Even if I'm allowed to use it or not, I still plug it in. So -3. So half times a -3. What do I get out of this thing? -1.5, because you're cutting -3 in half. So it's still negative, and it is -1.5. So that would be about right here. And it's a solid dot. Okay? Then we're going to plug in numbers that are less than -3, so I'll try like a -4 here now. So what's half of -4? 2. So that would be, so at -4, I'll be up at 2 now. And you get a sense for where this thing's going. It's going up. That's your graphs. That's it. That's a piecewise function. You graphed it. You're plugging in domain numbers and graphing the dots where they go. You have to make sure, are they open? Are they closed? For the starting point. Anyway, starting point. The rest of them are just where the line's going. Okay, questions on this? All right, you kind of understand. Now, if they're curves, don't just plug in 2 like I did. Plug in like multiple ones so you can see where this curve is going. Maybe it's going up and down and all that good stuff. You'll definitely want to plug in few numbers if it's a curve. Get a sense for if this thing's coming back up, if it's curving back down. That kind of thing. Okay, does that make more sense than what we did Friday? Friday we started with kind of a big one, especially the constant. We'll try another one of these definitely tomorrow. And definitely one more of these tomorrow, where we try ones with maybe like a dot, an actual single coordinate in it. We'll try ones with actual curves. That's what we're going to try to do. Okay, makes sense? Okay. All right. So let's move on. I'm going to leave that up there. Let's move on to differential quotients. This is the part that I want to stop with today. We'll come back to those tomorrow for sure. Differential quotient. We have that weird formula that we talked about the other day. This is the differential quotient formula. So if they give you some f of x, this is what you do to it. That formula will be on the board on test day. I think test for us is middle of next week, Wednesday or Thursday. I'm going to take a quiz on this stuff. That will be on the board. It's also, I believe it's printed also on the actual quiz itself, so you don't have to worry about like trying to memorize that weird thing. Now, let's talk about what this is. Like, what is this part here, just this top part? What am I doing here? Yeah, I'm adding an h in the original f of x problem. So it's like you're doing a functional substitution. You're taking some variable, which is x plus h, and I'm plugging into the original function, whatever that thing is. So it's modifying the original function, it's changing it. Then I'm going to be subtracting this. What is this item? Yes. Yeah, it's the original function. Just you're plugging x in. So it's whatever the function is to start with, whatever the formula is. And I'll give you the the equation. I think we started one on Friday. We'll do that one today. And then on the bottom, there's always an h. Always an h. Now the reason why is what we talked about on Friday is that this formula, what you're looking at, is actually slope. What it is. Okay? F of x's, if you don't when you plug in x to your formula and it spits out answers. That's what this actually stands for. So you're finding the difference in y's, and on the bottom, technically, this is a difference in x's. That's technically what you're doing. You're finding the difference between these, and you get rid of the parentheses. And what would happen here is that the x's would cancel out. So you just have the h on the bottom. That's what you're doing. So it is a slope. It's slope of any function, even if it's curved or if it's a straight line. The example I think we did Friday is we did a straight line, correct? It's like a linear function. I think the slope was like 3 in that problem. Okay? Today, I want to do that second problem. That second problem was a curve. It was something that actually has some type of curve, but I need that original function. So did somebody have it written down from Friday? Okay, I want to know what that original function was, please.
3x plus 2.
Oh, no, the second one. We did that. 3x plus 2 is the one we did Friday. What was the next one we started?
X squared plus 5x plus 6.
Okay. What we talked about on Friday is that this is a curve, right? X has a power of 2 on it. And, you know, you can factor this thing apart. I know it's factorable. And so this problem, you know, if you factor it, actually tells you kind of like we're going to hit negative 2 and negative 3 on the x-axis. And this thing is bowing upwards. And how I know it's going upwards is because all these things are positive, so it's going up towards positive infinity. That's a rule we're going to learn later. So this thing is most definitely a curve. So at any point, the slope is actually changing. It's not just going to be a single like constant number like we did on Friday, where that one was just, I think the slope is 3 all the way across the problem. The slope is actually negative here for a while, then eventually turns to 0, and then it turns to positive numbers. So the slope changes depending where you're at in the curve. And so what we're going to do here is we're going to do this formula here, and this will give us an actual equation we can work with. It'll give us something in the very end, like we can find the slope of this thing depending on what x number we're plugging into it. And I'll explain that here in a little bit. Well, I'll show you the example. This is going to be one example of differential equations today. Okay, so let's actually start with this. So I'm going to take my problem and I'm going to plug it into this formula so you can see how this works. And I think I started this Friday. Okay, so here's how it looks. I'm taking out the x, taking out this x squared, and I'm plugging the x plus h into it, right? Then I have that plus 5, taking out the x, plugging the x plus h, and then that 6 doesn't go anywhere. All right, what you're looking at here, and all in blue, this part here, this is this part. It's the original function. I'm just plugging in x plus h into all the x's. Does everyone see that? That's the original thing. Now, what do I have to subtract? Yeah, the original thing. X squared plus 5x plus 6. You always have to subtract the original function that you started with, because that's how you find the difference in y. Then on the bottom, what do I always put? H. Okay, what we're going to do here is we're going to simplify this problem down. It's going to take a little while, don't get me wrong. We're going to simplify this thing down, and it will give us an actual formula for slope, and I'll show you how it works. Like, how do we know this is slope? This is going to be a formula. It's not going to be just a constant number. Okay, so this first left part, I need to FOIL that out. There's actually 2 parentheses there. This is what it is. Okay? And I need to FOIL that part out. This part here, I'm just going to distribute the 5. That's not a big deal. This part, I'm going to distribute the negative sign. Not a big deal. Okay. Questions on this problem so far? If I started it, what I've got to you so far. Okay, let's FOIL that first thing out. So, can somebody tell me what am I going to get here? Good. X squared plus 2xh's, because when you FOIL, it'll be xh plus xh. There's 2 of them, and then h squared, like you said. That's good. So that's FOILing first out, or you're going to laugh on this thing. This is what you get. And it doesn't matter the order xh and the h axis written in, they're the same thing. So it's commutative, you can switch it around. Plus 5x plus 5h plus 6 minus x squared minus 5x minus 6. if you did all of your math correctly, here's what should happen. Anything that does not have an h on it should go away. That's how you know you did all of your math right. So let me walk through this. So x squared in the very beginning, that should go away. Okay? The 2xh, that's probably still there. The h squared is still there. The 5x's are gone. As I said, anything that doesn't have an h is going away. The 5h sticks around. The 6's are gone. You see how it works? It's just this weird little quirky thing. It always will leave you things with h's on it to begin with. And now I know that the very end will need to simplify this one more step. So what I'm left with so far is this. 2xh plus h squared plus 5h. And what I'm going to do here is I'm going to divide everything by h. That's still on the bottom, right? So when you do that, you literally, it's called the rule of quotients, right? Quotient rule where you can divide each item by each, because it's a rule of fractions actually. That I'm technically adding the fraction with the same common denominator. So I'm allowed to put the h on the bottom of everything and actually divide it. So what I'm going to be left with here is a 2x, because the h's would cancel there. The h in the middle, because h squared divided by h is h, and then 5h divided by h is just 5. And this is your formula. That's the final answer. That's simplified as far as you can. There's no fraction there. That's what should happen. And I'm left with that. What you're looking at here, this is an actual function. It's an actual formula, and it can tell you what your slope is at any point on that graph. Okay, so let me explain that. Like, why is this slope? How do I know that? So if I go back to that original graph over here, and I show you kind of just a real quick, like, non-detailed drawing of that, this original function. You know, and I told you that we factored it apart, and this is what the graph technically looked like. 3, and it looks something like this, right? And so slope was changing, because that's how we factored the original thing apart. Well, what this formula is basically telling me, the formula over there, what is that? 2x plus h plus 5. Okay, if you want to find slope on this thing, what you do is, in fact, is you assume, and this is the weird part, you assume h is 0. You assume h is 0, and so it gets to something like this. So if you have a bunch of things that have h's on them, those would all go away. And this is actually your slope formula in calculus, is what you do in Calc 1. You get to this formula, and you can plug in any x value you want, and it would tell you your slope at that exact moment. So if I were to plug in this number right here, what is that digit right here? -3. If I plug in -3 into this formula right here, and for the x's, it would actually give me what my slope is. So 2, plug in a -3. This would be a -6 plus 5. I get a -1. That's my slope at that exact moment. Would you agree that when you look at that picture, slope is literally negative? And now the number is the off part, but it's literally -1. If I go over here and I plug in like the number 2 into this problem, I plug in 2 into this formula here, this little bubble, I'll get 2 times 2, which is 4, 4 plus 5, which is 9, right? And that's the slope right here. Well, would you agree that that slope at that exact moment is actually positive, going up to the right? Okay? What would the number be right here? What would that slope be? Yeah, this slope right here should be 0, because it's like a horizontal line, right? Vertical lines are undefined slope, but like a horizontal line, the slope is 0. Well, that's the number right between 2 and 3. So it's negative, what, 2.5? So if I were to plug in a -2.5, 2 times a -2.5, that is -5, and I get literally 0. It tells you your slope at any moment on that graph. That's what it's doing for you. Question? Yeah, any minimum, any maximum will have a slope of 0, every single time. That's the inflection point. And it went from a positive or a negative slope to a positive slope. It has to hit 0 for a slope that's somewhere in between. That's a good observation. Question?
So why do we go through all of that work to try to find that formula there, only to get rid of it over here? To get rid of the h.
The h is something that we assume is 0. H doesn't affect slope. The differential quotient gives you your function all the way down there because there is some constant term. You'll learn about what h is later. That's a calculus concept. It's this idea that there's constants in a function anyway, because I can add any number I want. So it can be the decimal points and all the good stuff in between. So, because obviously I'm rounding numbers, obviously. So, yeah, it can give you the little details, and that's something we talked about in Calc 1. But does this give you an idea of how it's calculated roughly? Okay. All right, that's it for today. No. Now, hey, when the next classes come in, do not let them know what we're doing. I'll be severely upset.
Or if they do that, you should actually grade their paper.
What?
If they do that, you should actually grade their quiz.
I should actually enter it in your grade book.
Yeah.
Hey, that's a deal. If you tell them I'm entering that in your grade book.
That's what your grade for the second quarter.
Hey, I passed this one.
They can not pass it.
You passed it with what, like a B?
So?
Still passed.
We're only about 32% off, but you know.
Okay, what we're going to do tomorrow, we're going to definitely review that problem that we started with today. We need to review one.
We really can't.
Yeah, you can.
Oh, really, Johnny? I have not won it today.
Jack, I don't know if I'm going to get through this year. I can't do H.